Most AI trading content stops at the chat window. You describe a strategy, the model hands back a block of Python, you paste it somewhere, it throws an import error, and you paste the error back. That loop has a human bottleneck in the middle of it, and the human is the slow part. This build removes it. Claude Opus 5 runs inside the terminal through Claude Code with file system access to the project and a live connection to the Jesse algorithmic trading framework over MCP. By the end of this, it will have built a trend-following system on ETH, backtested it across 3 horizons, proven the entry rule isn't noise, and handed execution to a live exchange client. Every file and prompt is in the guide below. Let's start with the framework it's driving. Jesse installs as a Python package. One command scaffolds the project. One more pulls price history into a local Postgres instance. I'm importing ETH USDT from 2020 forward, and Jesse resamples the 4-hour anchor from the 30-minute candles automatically. The scaffold already writes a routes file, so we're editing that rather than creating it. And everything up to the execution section runs offline. No API keys, no exchange connection, no risk of the agent doing something expensive while I'm not looking. That's the engine. Now the agent needs a way to reach it. A small MCP server sits in front of Jesse on port 9700 and exposes the framework as callable tools. Import candles, write a strategy file, run a backtest, return the metrics as structured JSON. Claude Code discovers those at launch and calls them like any other tool. The reason to use MCP rather than letting the agent shell out to the command line is the return shape. Raw terminal output is a wall of text an agent parses with regex, and it misreads it. An MCP tool returns a typed object, so the agent reasons over numbers instead of formatting. That's also what makes the guardrails enforceable, because it can't claim it passed a test whose result it never received. And guardrails are next, because right now, this thing has capability and no constraints. Before the agent writes any strategy code, it gets a rules file. Claude Code reads this on every session start, so this is where the non-negotiables live. Objective, target sharp, risk per trade. Then the part that matters, a mandatory sequence it isn't allowed to reorder. Write the entry logic and run a significance test on it. If the rule can't be distinguished from random, change the rule, and don't touch sizing or stops until it passes. Only then optimize. Then run Monte Carlo, 1,000 iterations minimum. That ordering exists for one reason. Left alone, any optimizer will fix a bad entry rule by torturing the stop loss until the equity curve looks acceptable, and you end up with a system whose profitability lives in one tuned number. Forcing the test first means the edge has to come from the entry, or there's nothing to optimize. So here's what that test actually does, because it's the piece most people skip. It's a permutation test. The strategy took some number of trades with some average holding period and produced some mean return. So generate thousands of alternative strategies that take the same number of trades for the same holding period at random points in the same price series. Those form a null distribution. If the real rule doesn't clearly beat it, the rule contributed nothing. You were paid by the market's drift, not your timing. The output is a p-value, the fraction of random runs that matched or beat you. 0.30 means a third of coin flip strategies did as well. That rule is dead, and no amount of stop tuning revives it. One caveat, the null assumes trades can start anywhere with equal probability, and a trend follower clusters entries inside trending regimes, so the test runs conservative. That's the direction you want the error pointing. With the rules in place, the agent goes off and builds. Here's what came back. All the signal math goes into one module of plain functions. The strategy class imports it for backtesting, and the live executor imports the same file later. One source of truth, no drift between backtest and execution. The regime anchor reads only the 4-hour chart and answers one question, long only, short only, or stand aside. Price has to be on the correct side of the 200 EMA and the 4-hour SuperTrend line. Both, not either. That's what keeps it out of the chop. And it's the biggest driver of the drawdown profile because the 30-minute chart throws up plenty of setups against the higher time frame trend and everyone gets skipped. The trigger then waits for price to pull back into the mean and reclaim the fast SuperTrend line in the anchor's direction. We're not buying breakouts, we're buying the retracement inside an established trend because that's where the geometry is best. The stop sits just beyond the swing that formed during the pullback, so the risk leg is short and the trend leg it's measured against is long. Sizing is volatility scaled. Stop distance is 2 times ATR. And notice what isn't in this class. There's no take profit anywhere. That omission is the defining decision, and we'll come back to it. First, the numbers. Year-to-date, Sharp of 1.68, 30% net, 7% drawdown, a 3.8 to 1 payout. 2.5 years, Sharp drops to 1.35. 5.5 years, 1.34, 67% net, and the drawdown opens to 20%. Sharp degrading as the window lengthens is the honest signature of a real strategy rather than a fitted one. The recent window has the conditions the rule likes. The long window has everything else. If those numbers came back identical, the likelier explanation is that the parameters were shaped by the full history. The payout ratio moving the other way is more interesting. 3.8, then 3.95, then 4.02. Stable across 5.5 years of completely different market structure, which points to it being a property of the exit rather than of any regime. But the number that decides whether this is tradable is this one: 305 days underwater, 10 months between one equity high and the next. Which brings us to the part where most people would have deleted this strategy already. 7 trades in 10 lose money. That's not a defect being tolerated, it's the direct consequence of how the system exits. What it costs you is psychological. Long stretches of small losses punctuated by rare, enormous ones in unpredictable order. That's what the 305-day stretch was, a run where the big winners hadn't arrived yet. Which is the real argument for automating this, and it has nothing to do with speed. A human who's taken 14 straight losses starts editing. The code executes signal 15 exactly the way it executed signal 1, and the only way to harvest a fat tail is to still be in the market when it arrives. Now, the significance test proved the entry wasn't random. There's a second question it can't answer, and it's the last check before this goes near an exchange. How much of the performance came from the specific order the trades arrived in? Take the realized returns, resample them with replacement into 1,000+ alternative histories, compute Sharp on each. The original came in below the simulated median. If it had sat out in the right tail, the number would have depended on a favorable sequence, winners landing early and compounding into everything after. Below the median means the run was, if anything, slightly unlucky. The performance is a property of the rule set, not one arrangement of trades. One thing most people get wrong: shuffling the order of a fixed set of returns doesn't change Sharp at all, because mean and standard deviation don't care about sequence. Order shuffling is the right tool for drawdown, not Sharp. To vary Sharp, you resample with replacement, run the wrong one, and you get a distribution with almost no variance and conclude your result is bulletproof. And the line worth acting on isn't the median, it's the 5th percentile. So the system's validated, which brings us back to that missing take profit. The first version used a fixed 3R target. It backtested at a Sharp around 0.9 with a win rate near 45%. More winners, worse system. The target was capping exactly the trades the strategy exists to capture. The replacement is an ATR trailing stop that only moves one direction. Track the extreme reached since entry, subtract 3 times ATR, raise the stop whenever it improves, never lower it. In a strong trend, it follows price up for days. In a stalling trend, it catches up and the trade closes with whatever it made. That's where the payout ratio comes from. It gives back a fixed multiple of volatility in exchange for leaving the ceiling uncapped. At this point, everything works, and it's all still just a file on disk. So let's give it hands. Rather than writing an executor from scratch, I'm reusing the WEEX trader skill from the first build on this channel. A skill is a folder with a rules file and some scripts. The agent loads it when the task matches, so it already knows the auth scheme, the endpoints, and the demo mode rules. WEEX version 3 uses 3 credentials, and every request carries an HMACSHA256 signature. The prehash string is timestamp, method, request path, and body concatenated in that order, then base 64 encoded. Get the order wrong, and you get a generic signature error with no indication which part failed. Everything here runs against demo endpoints. The bridge script is thin. It pulls the latest candles, evaluates the same signal functions Jesse backtested, converts the ATR stop distance into a contract size, and submits through the skills client. Same logic in the backtest and in execution. That's the full loop, which is a good place to tell you why it isn't enough. This strategy run alone is not a business. It's one rule set exploiting one behavior, momentum persistence in ETH, and that behavior disappears for months at a time. The 10-month underwater period isn't a bug to engineer out. It's the price of admission for a single-edge system. The exit isn't a better strategy. It's more strategies that fail at different times. A mean reversion system on a range-bound pair makes money during the chop that starves this one. Combine uncorrelated return streams and the portfolio's drawdowns get shorter and shallower than any single components. That's where the agentic setup earns its keep. The bottleneck was never the ideas. It was the weeks of implementation and validation per candidate, most of which get thrown away. An agent that writes, tests, and rejects a candidate in an afternoon changes the economics of the search. Your job stops being the person who writes the strategy and becomes the person who sets the constraints and checks correlation between the survivors. And the guardrails matter more as you scale, not less. An agent running 50 candidates unsupervised will find 50 beautiful curve fits. Full build package is in the Discord, strategy files, rules file, both validation scripts, the WEEX skill, and the raw backtest exports. Links below.